Anchor is the easiest way to make a podcast. Anchor gives you everything you need in one place for free, which you can use right from your phone or computer. Creation tools allows you to record and edit your broadcast so it sounds great. And they even distribute your broadcast for you so that it can be heard everywhere. Spotify, Apple Podcasts, and Google Podcasts. So make sure you download the Anchor app or go to anchor.fm to get started. Hello guys, welcome back to another day, another session, another math lab session with yours truly, Angel Frett and Damian Anderson. So it is still this is a brand new week 5, day 9 of our math virtual lesson. In case, just to recap everything, in case you just now join us or you don't know what's going on, me and Damian team up together to do this for the students during this difficult time, during this pandemic. So we want to help those students that are struggling with math because we want to help them to have a better either math scores or to do good on their math tests or quizzes. Damien's doing 8th grade, I'm doing 6th grade. The reason why we pick those two grade levels is because those are the two because those are the grade levels that we want to teach. So that's why we chose those two grade levels. Now, we do also want to help other people as well. So if you're a high schooler, we will help you as well. So
yes, absolutely. So let's get this math session started, shall we? Let's get it started.
Yes. So without further ado, we are going to start with Damian because he has a brand new lesson on today. So I'm gonna let him take over from here.
Yes, so let's get into it, you guys. Last week, the past 2 weeks, I believe, we cover square roots and cube roots. And that was fun. That was a fun lesson. I hope that you guys understood what I was trying to teach you guys. But if you still are having trouble with it, just contact me. I will be glad to help you more with it. But I'm through square roots and cube roots, and I'm moving on. So this is a new week, which means a new lesson. So this week, just only this week, well, today and Friday, and then on next Monday, I will be teaching you guys rational and irrational numbers. So I'm so very excited about this lesson here. So very excited here to teach you guys of what I have learned when I was first introduced this, and I wanted to do this to the same with y'all. And y'all probably have already covered this, I believe, because when I was back in school, this was the first thing that we covered. So you guys probably already discussed this already, but if not, here I go with this. So let me share my screen and let's get this started with irrational numbers. Yes, go ahead.
Before you begin with the math virtual with your session on today, just a quick note. Today is the day where our lessons kind of intertwine. The reason why I said that is because I won't get into nationals, the number system later down the week. So to my 6th graders, make sure y'all pay attention to his lessons on today. Because 9 times out of 10, I will be referring back to his lesson on today. So make sure y'all pay attention, take notes or whatever you need to do for his lesson, because I'm gonna come back to if I can speak on today, I'm gonna use this lesson as a reference. So make sure y'all pay attention.
Yes, yes, please do, sixth graders. And I mentioned that in this video here that Andrew, he was going to cover this as well. So he could use my notes as a reference. So sixth graders, pay attention and also copy down notes, not just only my eighth graders, but sixth graders as well. So let's get this started here. And pay close attention. Okay, let me make sure that you can see this. Can you see this, Andrew?
Yes.
Okay, perfect. Perfect. All right, let's get started. All right, so let's get into our new lesson, which is rational and irrational numbers. So these are your notes here. So make sure you have your notebook and pencil out and take notes. So I have up here this I can't statement here that we used back in school, and I wanted to use it. So I can identify rational and irrational numbers. And I remember with these I can statements, back in eighth grade, my former eighth grade math teacher, when we do these, we always chant it out, repeat it out in class, and we would yell it out. Like she would say, go like this, like, I can, and we would say right back, I can, identify rational and irrational numbers, rational and irrational numbers, and say it 3 times. I can, identify rational and irrational numbers, rational and irrational numbers. I can, identify rational and irrational numbers, rational and irrational numbers, to get you pumped up for the lesson here. So I just wanted to do that here. So let's get into these notes here. So we have, and I got these highlighted, which means you need to highlight them as well. A rational number is any number that can be written as the ratio of 2 numbers. And I have here A over B, which is in the fraction form, where A and B are integers and B does not equal 0. It doesn't. Okay. So copy that down. It's any number, a rational number. It can be any number that can be written as a ratio of 2 numbers. So it can be written as a fraction. Rational number, it can be written as a fraction. And I'm going to show you an example. Then we have an irrational number, which is a number that is not rational, which means it cannot be written as a fraction. Now, irrational numbers cannot be represented by a terminating or repeating decimals. You guys should know what those terms are, because I covered that the first week, terminating and a repeating decimal. A repeating decimal, you guys, it just goes on and on, like 3.0000000. So that's repeating decimal. So copy this down here, reference back to those notes the first week that I cover repeating decimals, terminating, and a repeating decimal, because like I mentioned here, irrational numbers, it cannot be represented by a terminating or repeating decimals. And like I said, I'm going to show you guys the examples. So reference back to those notes there. Okay, copy it, and underline. If you don't have a highlighter, underline what I have highlighted. Rational number does not equal 0. And also underline any, because it could be any number can be written as a fraction, and then irrational number, underline that. And it is not rational, cannot be written as a fraction.
That can be a whole number.
And also
any number
cannot
for rational numbers
be represented by a terminating or repeating decimal. So copy these notes down, and then I'm going to show you guys an example. So I'm going to scroll down here. If you haven't copied this down, which is still up here, and let's look at some examples. So here are an example here. And these are my notes that I took back from school here. So, and I have here, please copy down these examples. You can write out, or you can just take a picture of it, whichever. Now I have over here, this example right here, rational numbers, and I said it can be written as a fraction. And you see where I underline can here. And then I have some examples down here. 1.2 is rational. 1/2 is rational. The square root of 4 is rational because the square root of 4 equals 2.
And that's a whole number.
See, will this work?
So that is a rational number.
The square root of 4 is 2. Hopefully I can write on this. Yes, it's 2. Okay? So these are rational and underline can. And then I have down here pi over pi, which that equals to 1.
And that's a rational number because that's the whole number.
To just 1. Then I have over here 10 pi over pi, which these two automatically cancels out.
So it's just 10.
This gives you 10.
Which that is a whole number. So it's a rational number.
So copy this.
If it's not a whole number, then it's not a rational number.
Now we see over here that irrational numbers, it cannot be written as a fraction. So underline cannot. Then I have some symbols down here. You got 3.759, so on.
Which is a decimal.
That's not a whole number. So it's an irrational number. Then you have pi over 2, which will give you some decimal points.
Not rational.
And that's not a whole number, so that's irrational. Then I have parentheses pi, which is 3.4, and I have over here 3.4, so on. That's not a whole number, so that's irrational. Then at the bottom, I got 10 over pi, gives you a decimal. Pi over 3 gives you a decimal. 2 pi over 4 gets you a decimal.
So if it gets you a decimal, it's not rational. Automatically know that it's an irrational number because it is not a whole number. Irrational numbers cannot, underline cannot, highlight whatever. So you know that irrational numbers cannot be represented by a terminating or repeating decimal. If you have decimals, irrational numbers, because those are not whole numbers. We want whole numbers. If you get whole numbers in your problems, that is a rational number. But if you don't, then it's irrational, because irrational numbers, it cannot be written as a fraction. But a rational number, it can be written as a fraction. 1/2, 3 over 4, 4/10. Those are rational numbers. Irrational numbers are not. Pi over 2, 10 pi over 5. Those are irrational because they give me decimals. Note that, note that, note that.
Remember up here, irrational numbers cannot be represented by a terminating or repeating decimal. Highlight it, underline it so you know it. You know it. Remember it. Then I have over here just some more examples.
Oh, I want to say something real quick.
Go ahead.
Remember that box that he put a box around, terminating and repeating decimal? That kind of sounds familiar. I hope y'all pay attention. I hope y'all did.
Absolutely.
So y'all should automatically know. Oh, this was that phrase is familiar.
Yeah, it should look familiar. Automatically should look familiar. Okay. So I'll give you guys time to copy these down. Take a picture of this, screenshot it. If you're watching this on YouTube, if you don't feel like writing all this down, just take a picture of it. And then there are also more rational and irrational numbers. You can add and subtract rational and irrational numbers, and then you can also multiply and divide rational and irrational numbers. But I will not cover those. I'm going to let Andrew, he is going to cover those, that lesson there. So I'm not going to cover that. I'm just only doing the basic here. But Andrew, he will cover that for me and also to his sixth graders. So I will not be doing that. So pay attention when he does rational and irrational numbers. He will be covering the adding, subtraction, multiplying, dividing. And you'll be doing those sets of problems. And when you hit high school as a freshman. All right, so hopefully you got these down. So let's move on to some example problems. Now, up at the top, I got another I can statement. I can locate rational and irrational numbers on a number line. Now, I'm not going to do it 3 times. Now, the direction it tells us, discuss each problem with your partner. Well, this is for if I was teaching right now. And then it also has to be ready to defend your answer. And we're going to do that. So, number 1, and make sure you copy this down. Which real number is closest in value to the number represented by point X on the number line? And then we have choices. Let me change my color pen to blue because that's my favorite color. All right. Now, let me scroll down to where. Now, which real number is closest in value to the number represented by point X on the number line? And then we see point X is between 10 and 11. So we need to find which multiple choice is correct and which is between 10 and 11. Now, we see that A, we got 87 over 9. Well, how are we supposed to know if it's between these points? Well, we can write it as a decimal. So what's 87 divided by 9? 87 over 9, you could just put this in your calculator, it's simple, and it will get you 9. It's going to get you 9.6 666 repeated. So you would just write this as that. And remember, I discussed this during the first week here. If it's a repeating decimal, keeps going on, just put a line over the top of it, which means that's a repeating decimal, which goes on forever. So you do not need to write out 9.6666666, keep going on. There's no reason for you to do that. Just put 9.6 and then put a line over top of 6. So you know that's a repeating decimal. Okay. I don't know why this thing changed. I was just testing it out here. Or just bad. That cannot be our answer because that is not between 10 and 11. So that's not right. Where to go? We're not going to. Okay. We're not going to choose. Okay. And if we look onto our number line, it is between 10 and 11. So that's a possible answer. So we will come back to that. Then if we look at C, we have 4 to the square root of 8. And that gives us 11.3. And we see that is not between 10 and 11 because that's past the answer. Then we look at D, 9.823. That's not between 10 and 11. So our answer right before it is B. Okay, I hope you understood how to do this here. When I give you a problem like this, which real number is closest to whichever they give you on the number line, which this example here, we see point X is between 10 and 11. So we need to find which answer choice that they give us is between 10 and 11. And they will show you these example choices right here. So you got to find the number that is between the points that they give you. You see in choice A, 9.6. That's not between 10 and 11. If X was right here, then yes, that would have been our answer, but it's not. So that's not it. Then we see B, we got 10.4. That is between 10 and 11. So that is our answer. If we go to C, we get 11.3. That is not between 10 and 11. That is over it. If it was between 11 and 12, that would have been our answer. Then we look at D, we got 9.823. That is not between 10 and 11. So look for your answer choices that gives us the number that is between whichever points that they provide to you. Please read the directions, because I know a lot of you guys do not like to, in math, you do not like to read the directions and you just work out the problem and you just get the answer that best fits for you. You need to read the directions of what they are telling you, because then you would get the answer problem incorrect. Because you know why? Because you did not read the directions that they provide to you. And read it closely, very carefully. Read it several times so that you know what you need to do. Highlight, underline important facts of how you need to do the problem. All right, let's move on. Let's look at another. Which real number is closest in value to the number
Underline
represented
closest.
by point D on the number line? And we see point D is quite toward -3 and to -4 on the number line. So we need to find where it's close between these 2 points here. Obviously, somewhere between here. We're looking for this here between
Circle if you have to, so you know.
And let's see if this will work.
Don't get confused with these problems,
So,
because they're very
if we
simple
look at
if you just
A,
read it.
we got -62 over 23, and this gives us -2.69. Okay. Is this closest to this point here?
No.
No. So that's not right.
Automatically exit out.
If we look at B, -3 to the square root of 2, that gives us -4.24.
Exit out.
Is that closest to -3 onto the number line? No. So that is incorrect. We go to D. We have a negative to the square root of 10, or the square root of -10, and this gives us -3.16. Is this closest to the number line? And if we look at D, obviously no.
So your answer is C.
So our answer is C, because it matches what's on the number line. These numbers do not. All right, let's look at 2 more examples.
All right.
So,
well, I'm gonna just do just this example here because it's quite different from the other.
Which value could be represented by a point between the
Underline between
numbers and the
know.
number line below? And we got 15 to 16, which is on the number line. So we're going to do the exact same thing, turn them all into decimals, and see which point is between 15 and 16. We want to find which is between 15 and 16. So we're trying to look between here, what's in between. So if we look at A, 298 over 21, that gives us 14. 14 is as we do 15, so that's not correct. Oops, that's quite lopsided. If we look at B, the square root of 245 gives us 15.6. Is this between 15 and 16? Yes, it is. Yes, it is. But let's check the other answers and see if we have something different. So we go to C. We got 3.8 squared, which gives us 14.44. Is that no? So that works out. Then we got D, 16.768. Obviously no, because that's past 16. So our answer is B. This is between here.
It's not hard.
So very simple. Let's go on to the last
one. All right, let me move. All right, let's go to here. Whoop. Okay, here we go.
Irrational numbers, rational and irrational numbers. So we look at number one here. It gives us put the directions, tells us put the following numbers in order from least to greatest. From least to greatest. So obviously we gotta put these numbers from least to greatest.
Not in any order that you want to, but what the question is telling us to do.
To greatest, and it still gives me a clue. -6, what does it give us in two decimals? 2.4. 2.6, it already is into a decimal. 12 over 3, it just gives us 4 because 4 times 3 is 12. Then we got 2 to the square root of 3, which is 3.4. Now, since we got these into decimals, let's put it in order. So first, it will be what? Obviously, the square root of 6. That's first. Then we have obviously 2.6 comes next. Then right after 2.6, what's next? Comes after 2, 3. Do we have any threes? Yes. 2 square root of 3, and then minus 12 over 3. This is our
Copy down. And read the question carefully. What if they ask you guys, put the following numbers in order from greatest to least, which I have down here, but I'm not going to show you. Then you will need to put it from greatest to least, not from least to greatest, or however you want to do it. Answer the problem that they are telling you to do. All right, let's go on to my last set of examples here.
There's 3 problems of this that I have here. And we still get the same I can statement, but it tells us the number below is between which two, and I forgot to bold between.
Underline between and two values.
And then it tells us to explain how you got your answer. Okay, so we got the square root of 30. The square root of 30. The square root of 30. Well, if we put this into a decimal, what will it give us as a decimal? It's going to give us 5.4772, so on, so on, so on. And then we can also round this to be 5.5 if we wanted to.
It didn't tell us to re-round, so we're just going to leave it as is.
So in this case, it is between which two values? Which two values? Well, and I'm going to type this out instead of writing this. So it is between, since the square root of 30 is 5.47, it obviously has to be between the numbers of 5 and 6, because 5.4, as we have up here, is between those two numbers. It would not be in any other two numbers because 5 and 6 is between, excuse me, I said this quite a little backwards. 5.4 is between 5 and 6. So that is your answer. It wouldn't be 4 and 5 because 5.4 is not between those numbers. It wouldn't be 6 and 7 because 5.4 is not between those numbers. 5 and 6 is because 5.4 is between 5 and 6. So this is your answer. Let's look at another 110. So we need to find between the two values. So the square root of 110, it gives us 10.488, so on, so on, so on. So in our text, 10.4 is between which numbers? 10 and 11. Because 10.4 is between these two. 10 and 11. 10 and 11. 10.4 is between those numbers. 10.4 is between 10 and 11. If you want to visualize this, put it on a number line. For the visual learners, I got a number line. I got 10 right here, 11 down here. We need to find what's in between 10.4. If you have to write it out, write it out. If you have to draw it out, draw it out. If you are a visual learner, do this so you can understand. Let's look at one last one. .7. 6 and 7 because 6.7 is between these two numbers. Okay. If you have to visualize it, do a number line. Six, 7. What's in between? That was quite a little bit. 6.7. Okay. So copy all these down. If you didn't copy everything because I was going quite a little fast, you could go back to it. And once you guys have copied all of this, enjoy this introduction video of rational and irrational numbers. So pay close attention to that video, which is starting now. So I don't know if let me stop the share. I don't know if I'm going to show that video. How much time do I got left? I probably went over.
You probably did, because we started at what, 7 something. So you probably did, but no worries.
So I am going. Well, I will upload that video up onto our YouTube channel. It's a very short video. So I'm pretty much finished with today's lesson of rational and irrational numbers. And what I was saying during that video, the key words, and I'm gonna say this again,
Rational numbers, you guys, if you didn't copy it down now. Rational numbers can be written as a fraction. We want whole numbers with rational numbers. If it gives us a decimal, that is an irrational number because irrational numbers cannot be written as a fraction. It's either a terminating or repeating decimal, which I discussed that the first week when we started this. The example problems of a rational number, you have 10, because that's a whole number. You have 1/1/2, that's a rational number. You have 10 pi over pi, which automatically gets you 10 because pi over pi, that automatically equals to 1. So your answer is 10. Those are rational numbers. Irrational numbers is where you have pi. That gives me 3.14, whatever pi equals to, the rest of the numbers. Then you have 2 pi over pi. I meant 2 pi over 2, excuse me. That gives me a decimal. Then I have 3.759. That's a decimal. So that's irrational. Know it. Know it. Rational numbers can be written as a fraction. Irrational numbers cannot. Okay? And then what I explained in that video that I'm just teaching you guys the basics. And then Andrew, he will be doing this, and he will be doing, I believe, the adding and subtracting, and then the multiplying and dividing. And you guys will be doing that.
Yes.
Also,
Adding and subtracting integers, which will be my lesson on today, as well as multiplying and dividing integers. So this is where I put it into depth.
So, sixth graders, I hope you was taking notes from my lesson because you will see them again. You will see them again. So, I am finished of my lesson here. So now it is currently in my time 6:50 and then 7:50 where Andrew's at. So we are going to take a mid-session break for 5 minutes and we will be back with Andrew's lesson. So we're now entering our mid-session break for 5 minutes. All right. We are now back from our mid-session break. Y'all excuse me, guys. I'm still chewing on me snacking. I was snacking during our break here. So we are through for our mid-session break, and now it is time for Mr. Andrew's Frett lesson on today. So, Andrew, it's in your hands.
All right. Thank you, Mr. Anderson. Like I said again, on Friday we actually introduced integers. Also, we wrapped up operations. The algebraic expressions, words slash how to write an expression, how to write a variable with an expression, how to solve GEM-DAS. Also, we talked about order planes and relations. We talked about domain and range. It was a lot on Friday. Also, we introduced a new unit, which is integers. If you pay attention to Damian's lesson earlier today, he kind of did a little sneak peek of my lesson, because my lesson is where I'm going to dive into rational numbers, which is part of whole numbers and negative numbers. So today we are going to talk about adding and subtracting integers. For this lesson, you might want to pay attention to, because you will get confused and you will get behind if you don't pay attention. I know I say this in every single session to pay attention, but this right here, this lesson is I highly recommend that you pay attention to this one. So let me go ahead and share my screen real quick.
Yes, and while he's doing that, do not be texting your friends. Do not be on your phone. Copy these notes down. Don't be doing anything that will distract you. Copy these notes down.
Yes, please copy these notes down, because this lesson right here, if you don't pay attention, you will get behind. I cannot stress that enough. All right, so today we are going to talk about, first we're going to do adding. First, we're going to do adding integers. So to add integers with the same side, add their absolute value. So in case, just to recap, on Friday, we talked about absolute value as well, how from the distance from 0. So the absolute value of 4 is 4. Because why? Because it's the same distance away from 0. Let me actually pull that up right now just to get a better understanding, kind of like a review a little bit. This will count as an interview part 1, review part 1, excuse me. So that's what we talked about. We talked about integers, how this number, any number from the number set, -3, -2, -1, 0, 1, 2, 3. Opposite is the same distance from 0. So we did, I did examples like -2 and 2 is the same distance from 0. -1 and 1 is the same distance from 0. Also, we talked about absolute value. Again, same, it's the distance from 0 on the number line. So -4 and 4. Also, I did these 4 examples, how the absolute value of -5 is 5. But if you put that negative in front of it, it will become a negative. So the absolute value negative absolute value of 5 is negative 5. So today we're going to talk about adding and subtracting integers. So this applies a little bit. So if the sum is positive, if both integers are positive. So like this example here, of course, everybody knows 8 plus 1 equals 9, or 9 plus 15 is 14. So that's one of the examples. Now the sum is negative if both integers are negative. So for instance, right here, negative 2 plus negative 4 equals negative 6. So it's kind of like you're adding first and then carry that negative over, which I'm going to show you just a second. So for example, let me get right eraser here. Actually, let me do something here. I'm going to do the screen. Okay. All right. So I'm just going to write this real quick. It's best for you to write it out just in case. So let me get let me do red. Okay, so I have an example here, negative 2 plus negative 3. Of course, 2 plus 3 is what? 5. Oh, hello. It's 5, right? So as you can see, they're both negative, right? So they're both negative. So this is the negative and this is the negative, right? So the sum is what? Negative. Because why? If both integers, oh my goodness, that is terrible. If both integers are negative, okay? So if it's kind of like the same, how negative times a negative is a positive, or if a negative times a negative is still a negative. This is the same scenario. Negative plus a negative equals a negative in this case. But I'm gonna tell y'all in just a second. So let's another one, just in case. So negative 1 plus negative 2. Let me do. So negative 1 and negative 2. Okay. Which will be what? So first, add up first, which will be 3. So is it a negative or a positive? Well, according to our rule right here, oh, hello. So y'all, so according to, I have to calibrate my pen here. So according to this rule right here, since these two are negative, it's gonna be negative. So it's gonna be negative 3. Now, if I see a positive 3, that is incorrect. Because why? Because you did not follow the rules that is right there. It's very important that you follow the rules. I was asking. Okay. All right, so we're gonna do another one. So this is going to be a little bit tricky. Tricky. So we have -3 plus +4. Okay. So this is where things get a little difficult right here. So pay attention. All right. So we have a -3. I was about to say a positive. And then we have a +4. So in this case, we are going to change this into a negative. Now you could be like, what? Huh? Listen. Because according to this rule right here, to add integers with different signs, subtract their absolute value. The sum is positive if positive integer's absolute value is greater, and if the negative integer absolute value is greater. So what's the absolute value of 4? It's 4. So is it greater than -3 or less than -3? Now it's greater than. So what we're going to do, again, that's why I changed it to a negative sign, to a minus sign. So -3 minus 4 is what? 1. You'll be like, okay, Mr. Andrew, I don't get it. How do you get 1? I don't get it. Like, how's it a +1? I thought it was going to be a negative. I told y'all, you got a -3 and a +4. We're going to flip that sign from a plus to a minus. And that's how I got 1. Okay. I'm going to take y'all a minute to write this down. It's very important to that you to know this. Otherwise, you will get behind. So I'm going to take a minute to write this down.
Yeah, so while
go ahead.
I had the same problem earlier with this, of what you're trying to do here. Yeah, it's just, it's a mess. Don't you just love technology? But
yeah.
As you guys are copying down these notes here, the last problem that he just showed you guys, -3 plus 4 is equal to 1. And you guys are probably wondering, well, how is that 1? Well, for visual learners, just do a number line. Draw you a number line and then label on the number line, some numbers. And do that. And then put a star or whatever onto -3. Then you see next we have a +4. On the number line, and I wish I could show you guys here, for example, you will go forward. You're not going to go backwards because your answer is not going to give you, some of you guys are thinking that the answer is -7 because 3 plus 4 is 7. So it has to be -7.
Yeah, ma'am.
Read the problem that they are. See, that is why it's so very important. Look at the question very carefully, because if not, then you're going to miss it. You're automatically going to miss it. So if you are still struggling, draw you a number line. Draw you a number line to better help you understand. That's all I have to say.
Which I'm going to do another example with the visual learners with this problem right here, because it can be tricky. Okay, it can be tricky. So, Damian, I'm going to need your help with this one, just in case. Give me a positive give me a positive number.
Okay, let's do a positive 9.
Okay. Okay. And then we're going to add, and then give me a negative number.
Let's do a negative 5.
All right.
Yeah.
I'm going to draw the number line over here. All right. Ah, great. Y'all did not see that. No. Why is it still pen? Okay, there we go. Gotta love technology. And it's only one day. All right. So here's another example for my visual learners. Make sure y'all paying attention. Okay. Got it. All right. All right. So positive 9 plus negative 5. All right. So what we're going to do first is we're going to determine if the sum is going to be positive or negative. All right. So we have a positive 9. So the absolute value of 9 is what? 9. And the absolute value of negative 5 is 5. Well, the sum is going to be positive because why? Because 9 is greater than 9. If you say 9 is less than 5, I don't know what to say. I really don't know what to say. All right. So we are going to we'll actually draw a number line here. Wait, I have to wait. Let me. Oh, I did that wrong. Oh. Whoop. Give me 1 second. All right. Gotta make sure it extends all the way. All right, so give me 1. All right, so we are going to actually do this on the number line. So we are going to do, I don't know if it's going to fit, but we're going to try. Okay, we're going to do 0, 1, 2, 3, 4, 5, 6. Oh, it's actually gonna fit. Okay. That's not gonna fit. Then over here, we're gonna do -1, -2, -3. It's like bunch up together. -4, -5, and -6. All right. I know it's not all the way up to -9, but y'all get y'all understand. All right, so first we are going to put a period or a dot at 9. Okay, that's your starting point. Point. All right, so we're gonna go back 5 spaces. So that's -5. Okay. Actually, I mean, okay. So for my visual learners, there you go. That's your answer. It's 4. You're like, how did you get 4? Well, I started at 9, which is this right here, and I went back five on the number line. So your answer is 4. That's your answer. Now, if you put -4, you're doing it wrong.
Mm-hmm.
That's incorrect. Okay. All right, so we're gonna move on to subtracting. Yay, right? All right, so to subtract an integer, we're gonna add its additive inverse. All right, so 6 minus 15. You can write it out. 6 plus -15 is what? 9. Okay. -7 minus 8. I rewrote it like I did in the previous. -7 plus -8 is -15. Okay. So these two examples. Okay. I'm gonna write it out because it will help. It's best for you to write it out, because if you don't, it's best for you to write it out. So to rewrite it. So for this one, we're going to write 4 plus -15. Okay. And then that's going to give you -11. Okay. -5 minus 8. We're going to rewrite this as, let me do this in a different color, as -5 plus -8. Okay. Again, just like with adding integers, just like before, we're going to add, which is going to be 15. No, it's going to be 13. I'm looking at that problem down there. Okay. Is it going to be a negative or is it going to be a positive? Was it going to be negative? Okay. Because you carry that negative over. Okay. Last one. Actually, 2 more. Page. Okay. Let's do this one over here. So we're going to rewrite this as 10. Oh. Hold on. Because hold on. All right, so for this problem right here, y'all gonna get behind. I know y'all will. Y'all gonna be confusing. All right, so 10 minus -3, and we have 4 minus -6, and you be like, how in the world do I solve this problem? Let me tell you. Let me help you. Okay? Doesn't hurt to ask. Please, that's why we're doing this, to help y'all out, so that y'all can get a better, to either help you out on a math test or to get a better score. Okay? So for this problem, we're going to rewrite it as 10. Oh, ooh, y'all cannot see that. Okay, we're going to rewrite it as 10 plus -3. Okay. And then for this one, I'm going to write 4 plus -6. So what I did was I just changed the minus to a plus sign. That's what I did. I'll give y'all a moment to write all this down. Oh, I'm sorry. I'm doing this wrong. Actually, don't write that. Don't write that. All right, so for this problem, we're gonna act like we're adding. I'm sorry. I'm just all over the place today. All right, so for this problem, for these 2 problems, we're gonna add. We're just gonna strictly add, okay? So 10 minus -3 is 13, okay? Okay, that's like same thing as 10 plus 3. That's the same thing, okay? That's the same thing, all right? So basically, yeah. So basically, we just add an add sign. We basically flipped those 2 signs. We change that minus and that negative to a positive. It's going to be 13. Just like over here, 4 minus -6. So we're going to just flip the sign. So it's going to be 4 plus 6, and it's going to be 10. That is your answer, and that is your answer. Okay? It's always best to double check your work. Okay? If you have a calculator, it's best to double check your work. It's very best. Because if you mess up and you get a different answer, or if you get a negative answer, then you did something wrong. Or if you got a positive answer and it should be negative, then you're doing something wrong. So it's always best to double check your work.
Absolutely. Absolutely. Because if you don't check your work, you guys, then half out of 10, then your answer may be correct, and then some are incorrect because you're not checking your work. So check your work. That was a great lesson, a really great lesson there. Really fantastic lesson. Yeah.
So next week, no, not next week. I'm sorry. Next week, well, might as well go ahead and get this out of the way. So next week, I won't be here. Might as well go ahead and get this out of the way since that's it next week. Next week, there will be no math virtual lesson. I am traveling. That's all I need to know. I am traveling. So yeah, so I will. So Friday will be my last day. Speaking of Friday, we are going to be talking about multiplying. Ooh. Again, this is where y'all need to pay attention. Pay extremely attention. Extremely attention. Like stop Snapchatting, be on Twitter, do your TikTok dance or whatever. Pay attention to this right here. It's very important, okay? Because Friday, this is where things get difficult for y'all, okay? Because not next week, Friday, we're going to talk about multiplying and dividing integers. Yes. And also we're going to talk about Also, we're going to talk about graphing in 4 quadrants. So we're going to go back. We're going to go reverse first, which is graphing in 4 quadrants, and then multiplying, dividing integers. Y'all pay attention. Stop doing your TikTok dance, y'all renegade. No. Be on Twitter, Snapchatting your friends. Pay attention. On Instagram, taking self. Pay attention. Because if you don't, you get lost. If you don't, and you get behind.
Especially in this subject, math. Yeah.
Oh.
Yeah. You'll get you'll get lost.
Real quick.
Real quick. So don't get lost and don't get behind. Because if you do, it's gonna take you a while to get back on track.
Yes, it will.
Yeah.
Some news on my end. We're gonna talk about fractions once I get back from my trip. We're gonna review of that multiplication and dividing integers and graphing. And graphing in 4 quadrants. And then we're gonna move right along to fractions and decimals now. Now, if you pay attention to Damian's lesson, we kind of did a little sneak peek. Again, did a little sneak peek. I warned y'all, this is where our lands intertwine with each other.
Yep.
We talked about terminating decimals and repeating decimals, rationals and irrationals. I'm going to be talking about fraction and decimals. That's when I get back. Okay. And then I'm going to go in depth of rational numbers and multiplying, dividing rational numbers once I get back from my vacation. So, y'all pay attention. Also new for this last session, I'll be helping out with Damian's lesson. So for that, I'll be helping him with intercept, with slope-intercept form and y-intercept of the line. So I'll be helping him out with that with his lesson. So there will be no 6th grade lesson during the beginning week of our 14th week. So I'll be helping him out with that lesson. This is something new for this last session. So I feel like he's going to need some help with that lesson. So I've decided to help him out with that one.
Okay. All right. So now, with me, you guys, I've got to mention during my part that on Friday, we will be doing classifying numbers with rational and irrational numbers. So that's on Friday. And then also, you guys, I'm probably going to do like some more practices and examples. And I may do like a sneak peek of doing multiplying and dividing rational and irrational numbers and adding and subtracting rational and irrational numbers. Don't know which one I'm going to do yet, but I am going to do a sneak peek of those to give you guys a head start of what Andrew will be doing, because you will see them again your freshman year. I did it during my freshman year, so you will see them again. Trust me, you will see them again.
You will.
Yes.
You will. Yes.
And yeah. They will see them again. They will see them again.
Not in just in their freshman year. You will see this in your senior year.
Yeah.
If you're taking AFM, if you're taking Math 1, Math 2, Math 2 Honors, Math 3, you will see this again. And if you're not getting it just like that, you're going to be behind.
Mm-hmm. 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 You will be
So,
behind. So stay on track. Stay focused. Don't get distracted. And then also next week on Monday, next Monday, it will be a review day of rational and irrational numbers. So be prepared for that. It's this lesson is quite short. There's not like a whole lot thing to do with this lesson, so this lesson is short. And then also next week on Friday is where I will be introducing a new lesson, which is scientific notation. Scientific notation. So
now, oh, I'm sorry to cut you off.
it's fine.
Realize they said scientific notation. To my sixth graders, we haven't even introduced exponents yet or powers yet. Okay, we will get to that later down the road because that's where we're going to talk about powers and exponents. He's doing a sneak peek of my lesson. Really, I don't know if y'all have realized during the past 5 weeks now, that he's doing a little sneak peek of my lesson, except for I think one or two lessons that he's doing a little sneak peek. Okay, so hypothetically, he's helping me out, really, because he's doing a little sneak peek of what I'm doing later down the road. So make sure y'all, again, I'm gonna keep on saying this too. Make sure y'all pay attention, because I might use the same example. I might use the same lesson. I might use the same example as his lesson. You never know. I might use the same format as him, but change the numbers. You never know what's going to happen. So make sure y'all pay attention.
Yes, absolutely, absolutely. And then also, when we finally wrap up our math session at the end of the school year, I will be teaching you guys of what you will be talking about when you hit high school, 9th grade. I'm talking to the 8th graders. So I will be giving you guys lessons of what you will be learning as a freshman in high school. So be prepared for that. That will be at the end of the school year when we wrap up our math session here. So don't worry about it just yet. I'm putting that out there that you guys will be learning what you will be learning and discussing about in 9th grade. So be prepared for that. And then also, I did not show my video today of rational and irrational numbers. Basically, it just gives a more explanation of it, of what I showed you guys earlier. So that will be up onto our YouTube channel. It's just 5 minutes long, just 5 minutes long. Just basically what I did, just a little more explanation to it. So.
Yeah, same my lesson. There's no video today. I do apologize for that. However, I will make up. I don't know. I will make up for it Friday, because since it's going to be a difficult lesson, I might have to add like 1 or 2 videos to it. So, because multiplying, graphing 4 quadrants is not hard. Okay. It's not hard.
No.
It's the multiplication, multiply and divide integers. Though that lesson right there itself is going to be hard for y'all, because y'all 6th graders, and this is new to y'all, and y'all not going to be on top of this. So it's gonna be difficult for y'all to master it. So I'm actually going to add 1 or 2 videos. Also, I'm gonna try to add some more for my visual learners. I'm gonna try to add some more like number lines or some artistic, even though I'm not artistic, but I'm gonna try to add some more things to my visual learners as well.
Yes, absolutely.
I guess I'm gonna end it here since I started it. Well, that is going to be it for our math virtual lesson. If you don't know Moto, which you should know by now, but in case you don't know, in case you are joining us now, same time, same grind, but a different lesson. And we will see y'all. Of course, I'm Andrew Frett, so I'm Mr. Andrew, and he's Damian
Anderson or Mr. Anderson.
We will see y'all on Friday with a different lesson. Y'all take care. Be safe out there. And see y'all on Friday.
Yes. Wear your mask.
Please do.
See y'all Friday. Take care.